So very good morning to all of you. So is my AV is okay? Okay, thank you, Shanti Prasad and Abhishek. So let us continue the class, today's class. So yesterday I was explaining, we were discussing about solving the problem. There were two questions were there. So the cost of total production is there. So till this point I've explained. So I was in a hurry, isn't it? So again I will be repeating it here. So cost C1 is obtained. This is a quadratic equation, and this is the optimal scheduling. We got PG1 and PG2 we got. So these values you substitute it in quadratic equation. So you will get the individual cost of each plant. So this is the cost of plant 1, 11,577. Then coming back to this, in the second quadratic equation, substitute PG2. That means wherever PG2 is there, so replace it with 91.11 megawatt. So you will get the respective cost.
ये बॉल्स क्यों दी है?
Aksham? I think is it Saksham Sharma's right number? Somebody disturb me. Okay, fine. Okay, Shanti Prasad for C1 you are getting 5255.8. So let me check these values. 255 4958. Okay, so please just you calculate. That's why I asked you to calculate it. So in this quadratic equation, substitute PG1 is equal to 88.89. Just calculate it and put the value whatever you are getting it, because even Shanti Prasad said the same thing. Even Abhishek also saying the same answer. So I'll go with that answer, 5255.88 C1, 5255.88. Okay, fine. So that I will be taking. Gunasmita also has given the same answer. So let us go with that answer only. Maybe some that's why I asked. I had a doubt here. So that's why I asked you to calculate it. 120 plus 40 into 88.89 plus 0.2 into 88.89 square. Hope you people have done the calculation properly, because majority of the students are giving 5255.88. This one is 5255.88. So that is the answer you are getting it, right? Okay, the second answer is both Shanti Prasad and Abhishek. That is cost of plant 2, 4958.56. 498.56 as given. So let us go with that answer only. Let us go with the, okay, Gunasmita also has given the same answer. So let us go with that answer only, because I had a doubt. So that's why I asked yesterday's class to please calculate it. Okay, so 4958.56, this answer is 4958.56. So others also you can cross verify, any discrepancies is there, you can inform me. Okay, as of now, let us go with the C1. C1 with 5255.886. The cost of plant 2, 4958, 4958. 0.56. Okay, that you do it. So with those values, now what is the total production cost? What is the total production cost? Cost of, you have to sum up all the plant costs. That means total production cost is equal to C1 plus C2. C1 plus C2 you have to do it. So as per my values I am showing it, but as per your values you add it. That is, what is that one? 5255.88 plus 4958.56, that you add up and put that one. So please you can correct these values here. So you are getting 10,214.446. So that is the value you are getting it, 10,214.44 is the total production cost. Here this cost is 10,214.44. So those corrections we make it anyway after the class. Once again I will check these values. So right now this is the answer. So please keep it out. Okay. Now this is the one first case. First question we have done it. Okay, fine. Okay, fine. Okay, second question is, what is the second question in the given problem we have seen? You see that one? I will go back and I will show it to you. Okay, fine. This is a problem we have to find the optimal generation of two units. That is PG1, PG2 we have found. Then for a total load demand of 180 megawatt and the corresponding costs. So corresponding costs C1, C2 we have found. And in addition to that one, we have found the total production cost also, total CT. Fine. So from apart second question, what is the savings in rupees power in this case, as compared to equal sharing between the two generators? Equal sharing between the two generators. So you see, that means when both the plant generators, plant P1 and plant P2 generators share equal load, that means there is a total load demand of 180 megawatt. So how much load will be shared by each plant under this condition? Equal sharing means how much load will be shared by each plant? How much load will be shared by each plant? If they are sharing equally, then what is the individual load on each plant? It is the individual load. The second question, you have to find out the savings in rupees per hour. In this case, rupees per hour is the unit for total production cost. So that's why in case one, in the first question, we have found even the total production cost. Now in the second case, we have to compare this one when the plants are sharing equal load compared to equal sharing between the two generators. That means total load is 180 megawatt. So when these two plant generators are sharing equal load, means on each plant, how much load we have to put? Can anyone answer? What is the load on plant 1, plant 2 under this condition? That means condition is what? When they are sharing equal load. When they are sharing equal load, what is the condition? So 90 megawatt. So you have given 90 megawatt. So that is obvious, no? So that is quite obvious. 180 is there. So equally these two plants has to share. So equally means 90 megawatts on this plant and 90 megawatts on this plant. So that is how you should understand when it is sharing equal load 180 megawatt. Equal load means here 90, here 90. Total is 180, isn't it? That is PG1 90 megawatt, PG2 is also 90 megawatt. Hope you have understood this one when they are sharing equal load. So let us go back and find out the case 2 here. So now you see here PG1 90 megawatt, PG2 also 90 megawatts, case 2. Understood? When they are sharing equal load, what is the total production cost we have to find out? What is the total production cost? Can anyone tell how to find out total production cost under this condition? Equal distribution. Under this equal distribution. Under this equal distribution, how to find the total production cost, because the question says savings in rupees per hour. That means you have to find a total cost when they are sharing equally, and when they are not sharing equally, that is with the optimal sharing case 1, you got the total production cost. So you take the difference between these two total production costs. So that will be your savings. That will be your savings. That is the difference between the total production cost between case 1 and case 2. Case 1 is your first question. Case 2 is your second question. So how to find out the total production cost now? Putting the value of 90 in both equations. Which equations we have to substitute? PG1, PG2. We have to substitute it in quadratic equation, that is cost equation. We have to substitute this one in cost equation or quadratic equation. So what are the quadratic equations we have considered for C1? This is the quadratic equation we have considered. So PG1 is 90 megawatts now. So substitute 90 here, 90 square. So you find out what is the C1 value. What is the C1 value? Can anyone tell what is the C1 value? Under this condition, when they are sharing equal load, the cost is how much? 5340. Abhishek has given 5340. So let me check the answer here. Yes, 5340. Now my answer and your answer is matching. Even Saksham has given the same thing. Okay, Sumant has given even C2 also. C2 also you find out. That means in the second quadratic equation, substitute PG2 of 90. So you can substitute it here. Okay. Substitute it in the second quadratic equation. So what is the value? Okay. Second value I'm asking. So I will give the value. You can check it out here. This is the substitution, 4,875 rupees per hour. Okay, most of them has given. Saksham, you have given some mistake, I think. Just you calculate it. No problem. So 4875 rupees per hour. Fine. Now what you have to do? Find out the total production cost in this case. Find out. Okay, Shanti Prasad has already given the savings. Let us check. At least somebody is working faster than me. Okay. Okay, total is 10,215. Abhishek has given. So let us check C1 plus C2 is 10,215 rupees per hour. C1 plus C2. So add these two. So therefore that will be your cost. So now what is the savings? Now what is the total production cost earlier? What is the value we got? Here, what was, I think here my value I am having it. I think you may be having your value with right values, isn't it? In case 1, you have total production cost. So what is the difference? What was the first cost? First case, what is the total cost? With your values, with the right values. Can anyone put it there? Okay, 10,214. 10,214. Okay, fine. Now here it is 10,215. So what is the difference here between these two total production costs? The total production, the difference between these two costs is 0.56. Is it so? Abhishek, Shanti Prasad has shown savings as 465. Please check it. Check it. Lokesh also giving 0.56 rupees per hour. Okay, Abhishek, now you are corrected. Okay, Shanti Prasad. Okay, so this is the savings. Okay, as compared to both the cases. However, once again, please check the calculations of C1, C2 for both case 1, case 2. Then you find out the savings. Even I will check any discrepancies is there. Now, as of now, the savings is 0.56 rupees per hour. Okay, so with the optimal generation and with equal sharing, so we have seen the total production cost and the savings here is 0.56. So which cost is less among these two? Which cost is less? Case 1, 10,214 you have. That means when it is optimally distributed, the cost is less, total production cost. When you are giving equal sharing, cost is slightly more. So obviously it is the thing. Mohan Kumar, you answer to my question. Don't say that you are present. You started attending classes recently and you joined late and you say you are present. Don't bother about your attendance. This is for Mohan Kumar. Okay, fine. So that is the thing, you have to do it. I think you have understood this one. So these are the equations repeatedly repeated. So the questions will be different here. Only the questions will be different here. So that quadratic equations remember, you should remember. Then what else you have to remember? The incremental fuel cost. Incremental fuel cost you should remember. These two equations. So within these two equations, so it will vary. And you know how to find out the cost after getting the PG1, PG2. Sometimes the lambda values will be given. From the lambda values, we have to find out PG1, PG2. Now, how to calculate the lambda here? How to calculate the lambda, that is incremental fuel cost? We have done it here already in the back slides. If you see, back slides, you see this one. What is the lambda value? 75.56. You know how to calculate lambda. That means you take derivative of your quadratic equation, then whatever PG generation is there substitute, you will get the incremental fuel cost lambda. That is here in this case it is 75.756. Sometimes what they will do, they will give the lambda value. They will give the lambda values. So when they give lambda value, see you substitute lambda, easily you can find out PG1 here, reverse way. So this also you should know that one. So from this lambda, you can find out PG1 and PG2. So once after getting PG1 and PG2, substituted in cost equations, so you'll get the cost of each plant. Then add up all the costs, that will give you total generating cost or total production cost. Okay, fine. So then coming back to, so hope you understood this problem. Only thing is within these equations, it will be asked. Okay, now let us take the next case. Okay, next case will be this one. You see here, economic dispatch neglecting losses, but with the generator losses, sorry, limits. First case, whatever we have done, with the numerical examples also we have solved, that is economic dispatch, neglecting losses, as well as no generator limits. Now here case 2 we are dealing it with. Now here case 2, economic dispatch, neglecting losses, so with generator limits. Understood? With the generator limits. Now what happens? Earlier in case 1, economic dispatch, neglecting losses and neglecting the generator limits. So what is the incremental fuel cost equation we got? incremental. What is the criteria for optimal dispatch? Criteria for optimal dispatch is dci by dpi is equal to lambda, is equal to lambda, or you can write it less than or equal to lambda. So in turn, when we write this one an equality constraint, so how we have written dc1 by dp1 is equal to dc2 by dp2 is equal to etc dcng divided by dpng is equal to lambda. So that is what I have given it, isn't it? So there, this is your incremental fuel cost. It is not less than or equal to. I will explain this one later. Don't bother about this one now. This less than or equal to. Earlier, what is the optimal dispatch condition? Was dci by dpi is equal to lambda. That you remember it. So why less than or equal to? Now I will explain under this case. Now in this case, we are neglecting losses, but we are considering the generator limits. So let us see this one, how to obtain economic dispatch. Now, as usual, you know what is the objective function in this economic dispatch. You should know this one. Already I have defined, that's why I given equation 3. Already we have defined this one earlier slide. So therefore, objective function is Ct is equal to sum of Ci's. What is Ci? Is the cost of ith generator. Cost of ith generator. What is Ct? Is the total production cost or total generating cost is equal to sum of the cost of all the generators, where I is where from 1 to ng. What is objective function is to minimize this cost. Minimize this cost, total production cost, such a way that it should satisfy the constraint 1. Equation 4, already I have explained this one. What is that one? Subjected to the total generation must be equal to total load demand. With the pictorial representation, I have explained it. With the pictorial representation, I have explained it. Isn't it? This is equation 4. I have not given any new numbers. Whatever the numbers earlier I have given, the same numbers I am using it here. It is not a new numbers. So this is your objective function. This is your equality constraint. I told constraints are of 3 types. One is equality constraint. The second one is inequality constraints. In inequality constraints, there are 2 types. That is, one is greater than or equal to. The other one is less than or equal to. Please remember these constraints. So in the earlier case, we have considered only this equality constraint. But in this case, we have to consider the other one. What is the other constraint? With the generator limits. With the generator limits. What is this generator limits? Like I have explained, what normal value of voltage at buses will be 1 per unit. However, a tolerance of plus or minus 5% is permissible. So that means what is the range? 0.95 per unit to 1.05 per unit. That means what is the minimum value? 0.95 per unit. What is the maximum value? 1.05 per unit. That means this voltage has got lower bound and upper bound. Lower bound is 0.95 per unit. Upper bound is 1.05 per unit. Fine. So similarly, that is for voltage. On the same lines, we will have a generator limits. That means what is the minimum limit on this generator and what is the maximum limit in terms of megawatt. So what is the minimum loading that should be available? Without that minimum loading, operating generator is not a efficient procedure. Always you have to operate generators with a minimum load, then only the efficiency will be good. Otherwise the efficiency will be very bad and regulations will become poor. So that's why we should have a limits on this one generator. So this generator limits constraint also we are going to consider additionally here. So these are the generator limits. So what is PI? Is the generation at ith plant. Is the generation, real power generation at ith plant. Understood? Must be greater than or equal to obviously PI minimum. Must be greater than or equal to PI minimum. However, it must be less than or equal to PI max. That means what? Whenever real power generation is there, it should be within the lower and upper limit, isn't it? That means it has to operate between the lower bound and upper bound. So that's what the same constraints we have represented here. The generation of real power must be greater than or equal to Pi minimum and must be less than or equal to Pi maximum, where I is varied from 1 to ng number of generators. Understood? So this is the additional constraint we are considering it here. This is the objective function and these are the two constraints. Earlier we have considered only this constraint and we got the optimal dispatch condition. Now we are considering additional one. So this is your optimization model or the mathematical modeling. This complete objective function with these two constraints is known as your optimization model. You may get it in a gate question. They will give the equations. Which one corresponds to your optimization model for economic dispatch, neglecting losses with the generator limits? Then you have to choose right answer. Clear? So this is what you should remember, or this is the mathematical model of your economic dispatch problem in which losses are neglected and generator limits are considered. Now, how to consider this inequality? This is called as inequality constraint. Inequality constraint. This is equality constraint. So how to consider this inequality constraint? So till this point it is same. Till this point it is same. This one and this one. Whatever the optimal condition we got remains the same here also. But how to take care of this additional constraint? That means suppose you are calculating the real power generation at ith generating plant or ith generator. Okay, if it is below PI minimum, if it is below PI minimum value, the calculated value of PI, then you have to, this PI value, suppose minimum value is 20 megawatt, you assume it. You assume it. That is the minimum value, minimum loading. Suppose the calculated value of PI, you got 15 megawatt. So the calculated value has violated the minimum value or minimum bound, isn't it? So therefore, what is the real power generation at PI, that is ith generator, must be pegged at the minimum value of 20 megawatts only, not 15 megawatt. It should be 20 only. Whenever it violates the lower limit, whatever the lower limit is there, that has to be assigned to that particular generator. Hope you understood this example. PI minimum is 20 megawatt. Okay, that is the minimum value. Suppose the calculated value of PI, you got 15 megawatt. So it has violated the lower bound. So what is the value of PI? You cannot take 15 megawatt. You have to take PI is equal to 20 megawatts only because that is the minimum value. So therefore PI is pegged or clamped or clipped or operated at 20 megawatts only. Fine. That is with respect to lower limit. Now coming back to upper limit. Suppose the calculated value of PI violates the maximum value. That means if Pi max is greater than or equal to Pi, that means what happens here? What happens if it is less than, if it is greater than Pi max? Pi is greater than Pi max. That means Pi is 15 megawatts. Same example let us take. And Pi max is 100, sorry, Pi max is 100 megawatt. Okay. Now Pi calculated value, you got it as 110 megawatt. What you are going to do? Pi calculated is 110 megawatt. Pi maximum is 100 megawatt. So what happens here? The calculated value of Pi violated the maximum bound, the maximum value or the upper bound, upper limit. Any way you can call. So what you should to take? The calculated value is 110 megawatt, but the maximum value is 100 megawatt. So therefore, the PI must be operated or pegged or clamped at which value? At which value? Whether it should be operated at 100 megawatt or 110 megawatt. Hope you understood this example. Answer I want. The example I have explained it. Now I am asking the question. Saksham Sharma has given the answer. Okay. Pi max is 100 megawatt. Now the calculated value is 110 megawatt. So therefore calculated value violated the maximum limit. So therefore the generator at ith plant must be operated with 110 megawatts or 100 megawatts. That is my question. So obviously it has violated the upper limit, because based on this one only we are going to solve one numerical. So that's why I'm telling it. Hmm? So it will be pegged at maximum limit. That means even though the calculated value here is 110 megawatts, but the maximum value is 100 megawatts. So PI will be clamped at 100 megawatts only. You cannot violate. Clear? So if it violates minimum limit and it is clamped at minimum value. If it violates upper limit, then the PI will be clamped at upper limit only. This is the equation. Please you remember it. Understood? This is what you have to remember it. Hope you understood this one. So this is how we are going to consider this inequality constraint. This and this, whatever we have done, procedure we have followed in the earlier case remains the same. But how to take care of this additional constraint is, as soon as you calculate PI, you check whether that is within the limits or not. If it is within the limits, don't bother. If it is violating, then if it is violating the lower limit, then you clamp this value at lower limit. If it is violating the upper limit, then you clamp this value of P at upper limit. Okay, so this is what you have to do it. Fine. Hope you understood this one. Now with this one, now what you are going to say? Let us see this one. We have to apply the Kuhn-Tucker conditions. We have to apply the Kuhn-Tucker conditions to this equation, which complements the Lagrangian conditions to include the inequality constraint. Till this point, we have applied Lagrangian conditions, isn't it? Using Lagrangian multiplier, we have done it. Now we got additional constraint. So how to get that one? You apply Kuhn-Tucker condition. You apply Kuhn-Tucker condition so that will complement the Lagrangian conditions which we have studied in the earlier case. This will include the inequality constraint. That means how to include this inequality constraint? By applying Kuhn-Tucker conditions. So what are these Kuhn-Tucker conditions? Because all these Lagrangian Kuhn-Tucker conditions will comes in optimization methods. So earlier people had a subject called as operation research. Now it is not there, I think, for you even in electives. So earlier electrical students used to study this subject, operation research or optimization techniques. There are so many techniques are there. Or you might have linear programming, non-linear programming, that is simplex method, big M method, isn't it? Two-phase simplex method. All these are the techniques, methods used to get the optimal solution. I think you might have studied in mathematics some of the things. Okay, so similarly here Kuhn-Tucker conditions we have to apply it in order to include this one. So these Kuhn-Tucker conditions will complement the Lagrangian conditions. So what are those Kuhn-Tucker conditions? Let us see here. The necessary condition for optimal dispatch is, now you see the necessary, this is important. The necessary conditions for optimum dispatch is, first one is dci by dpi is equal to lambda. This is what? When it is within the upper limits. If it is operating within the limits, that means if Pi is less than or equal to Pi minimum and less than or equal to Pi maximum. That means if it is not violating either a lower limit or upper limit, then what is the necessary condition for optimal dispatch? dci by dpi is equal to lambda. Please remember these conditions, Kuhn-Tucker conditions. Number one. And now I said dci by dpi is less than or equal to lambda when pi is equal to pi max. When pi is equal to pi max. For pi is equal to pi max, that means whenever you are clamping the value of pi at P max, then what is the condition for optimal dispatch? It must be less than or equal to lambda. Now, for Pi is equal to Pi minimum, that means whenever it violates the lower limit, Pi will be clamped at Pi minimum, isn't it? For that one, this constraint will be in reverse way. So what is the condition for optimal dispatch? When it violates the lower limit, then Pi will be clamped at Pi minimum. So what is the condition? dCi by dPi must be greater than or equal to lambda. So till this point, you have to explain. So before answering it, read the question carefully. So economic dispatch neglecting losses with generator limits. So whatever we have analysis, we have made it earlier, isn't it? In case one, in continuation with that one, you have to add these things. You have to add these things. Don't do only this part. Understood? In the test or examination, if they ask, explain the economic dispatch neglecting losses, but with the generator limits, with the necessary or appropriate equations means, the case one you have to repeat completely. Then you have to continue this one with the inequality constraint. This additional information you have to provide it. Suppose if they ask, explain the economic dispatch with neglecting losses with no generator limits, then you explain only case one. No need to explain this one. So that's why please read the question carefully in test and examination and answer it. So this is your necessary condition for optimum dispatch. Within the limits, it is same as that one of your case one. If it is violated upper limit, then it is less than or equal to. If it is violated lower limit, then it is greater than or equal to. Hope you understood this one with the inequality. This is what I explained it already. If any plant reaches a maximum or minimum value, the plant becomes pegged at that particular or at the respective limit. This is what I explained. If it exceeds the lower, that means violates the lower limit, then the PI will be pegged or clamped at the PI minimum. If Pi violates the maximum value, then Pi will be pegged or clamped at maximum value. This is what already I said it. So in effect, the plant output becomes constant. Means what it says, suppose you assume it, this Pi is violated the lower limit. So your Pi is clamped at Pi minimum, isn't it? So therefore, any additional load is there that will be shared by the different plants. So the load on this particular plant will become constant. That plant will become constant. Hope you understood this one. The plant output becomes constant if it violates the limit. Pi is violated the minimum value. So Pi is pegged at Pi minimum. So any additional load is there that will be taken by the different plant. Not on, suppose two plants are there. Plant 1 has violated the lower limit. So it is pegged at lower limit, plant 1. Any additional load is there, it will be taken by plant 2 because plant 1 becomes constant till a particular value of incremental fuel cost. That we will see it in the numerical example, you will come to know that one. So plant output becomes constant whenever this Pi value is pegged at either Pi minimum or Pi maximum will becomes constant. That point you should remember. So only the plant which is not violated must be operated at equal incremental cost. The same thing I have explained. The violated plant, the output becomes constant. The plant which is not violated should operate, should alone operate with equal incremental fuel cost. Hope you understood this one. So this is the thing. So now this is the numerical examples. We will see that one in the next class. This is the example which clearly explains about this inequality constraints. So this is a theoretical approach of this one. Hope you understood this one. So any doubts? Next class I will continue. So how to calculate savings? Okay, in the previous case, you got the total production cost for question 1. And in the question 2, also you got the total production cost. The difference between these two costs is your savings. This is how you should calculate, Saksham. In the previous problem, there are two questions. 1 and 2 is there. So what is the total production cost you got in case 1? And what is the total production cost you got in case 2? The difference between these two total production cost you have to take. You got 465. Okay, that's what. Please, you check that numerical problem again, because the other person also given the answer as a 465. Saksham also is giving 465, but most of them has given it as a 0.56 rupees per hour. Even I will check the numerical values. I will clarify it. Even you people will check once again, because you people are getting different answer. Fine. We will check and we'll give the clarification in the next class regarding this numerical value. Okay. Thank you, one and all. Take care. Good day.